Okay, let's give you guys some practice. So use integration by parts to integrate this. The hard part is in deciding on how you should make your u substitution. Should you make this to be your u, or should you make this to be your u? Remember, we're working our way down the list here. So what you've got here, what you've got here is an inverse function. You've got an inverse function here, and then here you've got an in a way an algebraic function. Because the inverse function is higher up the list, you should make this to be your u, and then you should make this to be your v prime. Okay, and then if you continue the process, you will get to this stage here. You will get something along the line of this, and then here you've got to use you've got to break this up into a over x, and we've done this before. So it would be bx plus c over x squared plus 1. Well, if you don't understand what I'm talking about here, then you have to track back one of the earlier videos. But we've done this many times. In order to integrate something of this form here, you would need to break it up into this and into this. Well, do whatever you want, integrate this. Okay, so press pause and have a go. Okay, so to do this, make this to be our u. So make this to be our u, and then make this to be our v prime. So this is our v prime here. Okay. Well, if u is inverse tan, then differentiate inverse tan, and will give you this. And remember, we've done this many times, and I've asked you to be able to do this by heart. Okay. So you should be able to differentiate inverse tan of x. It will give you this. And then well, if v prime equals this, then if you integrate v, it will then give you this. So now blindly follow this instruction here. U times v. Well, u times v would give you hang on, let me think. Would give you minus 2 inverse tan of x blah 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 here over x. Okay, and then you've got your minus here, and then the integral. Now u prime times normal v, u prime times normal v, that will then give you, because you've got blah 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 blah, it will then take you to this. It will then take you to this. Okay, it will then take you to this. So now now we need to evaluate this. We need to evaluate this. So let's just concentrate on this bit now. So let's imagine, well, this is exactly the same as this. So now we need to break this up into one fraction plus another fraction. Looking at this, make sure you can't break this up any further. If you have, like, let's say if you have this, then you can break this up. You can break this up as plus 1 and then x minus 1. But because if it's a minus, you can break it up. But here is a positive, so you can't really break it up any further. So so this one here, break it up as one fraction plus another fraction. So now it's a matter of finding out a, b, and c. Okay, so now looking at this here. So currently we are here at the moment. So now time, so here you've got one fraction equals this fraction plus this fraction, times everything by x. So now we're going to times everything by x. So times this by x, and then times this by x. So that will then give us this. And then now we can let. So now we can let x equal 0. So when you let x equal 0, this thing here will be well, the whole thing here will be 1. This whole thing here is 1. And then if you let x equal 0, then this you got a 0 here times this whole thing here will be 0, and then a equals 1. Well, if you let x equal 0, then a here will be 1. So a is 1. Okay, and then now going back to where we were before. We were here before. Now that we know a equals 1, remember, we know a equals 1. Now times everything by so here you've got one fraction equals this fraction plus this fraction here, times everything by this whole thing here. So if you times everything by this whole thing here, then you have this. Okay, because if you look at this fraction here, if you times by x and then x squared plus 1, you can see that this would get cancelled out with this, leaving you with this. And then, well, if you times everything by 1, it would take you to this stage here. Now earlier we know that a equals 1, so we can put 1 into here. That will then give us this. And then now take away 1 from both sides. That will then give you this. And then now take away x squared from both sides. That will then give you this. So now you just need to select A and B in such a way that this whole statement is true. Well, if you look at this here, you've got minus x squared here, and you've got an x squared here. You've got no x term over here. You've got no x term on the left-hand side. Well, when you get to this stage here, you have to select B and C in such a way that this statement makes sense. Well, if you look at this here, the coefficient of B must be 1. It must be 1. And then the coefficient of x here must be 0. And then the whole statement here makes sense. So overall we know that we know A equals 1, B equals -1, C equals 0. So this thing here, so this thing here, we can break it up as this, take away this. Okay, so that will then take us to here. So hang on. So earlier we were at this stage here. We needed to evaluate this. We needed to integrate this. There are other ways of finding the integral of this, but let's break it up as well. We needed to break this up. So now so if you break this up, it will then give you this. Okay. And by the way, rather than having to rewrite this every time, let's just call this capital I. So let's just call this capital I. So capital I equals this thing, which is this thing here. But then earlier we know that we can break this up as one fraction, take away another fraction. So this thing here is exactly the same as this thing here. Okay. So now you can integrate this and then integrate this. That will then give you that will then take you to here. So from here, hang on. So from here, let me think. From here, oh yeah, from here. Oh, when you are here, always keep an eye out on something being the derivative of another thing. So if you and then when you're integrating, always try and keep an eye out on these things here. Keep an eye out for this. Keep an eye out for this. Well, if you integrate this, then this here is the natural log. So when you look at this here, this is of the form this here. This here is of the form u prime over u, because here you've got, if you look at this here, if you differentiate this, it will give you 2x here, and then this x here is very similar to this. So always keep an eye out for something being the exact derivative of another thing. So here, if you push this 2 back into here, then here you've got something that's the exact derivative of another thing. Because if you differentiate this thing here, it will give you 2x, which is exactly the same as this. So really, when you look at this here is in the form of u prime over u. Well, if you integrate this, it will give you the natural log of u. So when you come to integrate, try to keep an eye out on something being the exact derivative of another thing. So here, push the 2 back in here, then you will get to this. So now you can just integrate. So hang on, let me think. So we are currently here, and why is this exactly the same as this? So, okay, it doesn't matter. So we are currently here. If we are currently here, then we are currently here, because they're both exactly the same. And then now it's just integrate. Integrate this. It will give you this, and then integrate this. It will then give you this. Okay, and because this thing here is always a positive. Because this thing here is always positive, we don't actually need the absolute sign. We can just write it as this. Okay, so overall the answer would be this.